Hello friends, welcome to Shibi's chemistry classes. Today is the third video of chemical bonding chapter, and in this we are going to study about structure of covalent compound. Structure of covalent compound. First we will take hydrogen molecule, and you can see that hydrogen molecule is formed by the combination of two hydrogen atoms. We know the atomic number of hydrogen is 1. So it is short of one electron to complete the duplet and get the configuration similar to helium. Now we will draw the structure of this hydrogen molecule. This is the structure before combination. This is the one electron present in the valence shell, and after combining we get this type of arrangement. So these two electron belongs to both the hydrogen atom, and it is stable now. We'll make the Lewis dot structure also. So this is the example of single covalent bond, and it is non-polar. This is non-polar and single covalent bond. This much is clear. Now second we will take example of chlorine. Chlorine molecule. We know the atomic number of chlorine is 17, configuration is 287. So you can see that it is short of one electron to complete the octet. So that one electron it will gain by sharing with the another chlorine atom. 7 electron in the outermost shell, 7 electron in the outermost shell. This is one chlorine atom and this is another chlorine atom. After combination, so if we count the number of electron, this chlorine atom has 8 electron now and another chlorine atom has 8 electron now. So both are satisfied with their octet complete and form a stable molecule, that is chlorine molecule. And the Lewis dot structure is this is the Lewis dot structure. It is also an example of single covalent bond molecule and it is also non-polar. Why it is non-polar? Because the sharing is taking place between identical atoms. So due to no electronegativity difference, there is no charge separation over here. So the compound is non-polar. Third, we will take oxygen. Oxygen atomic number is 8, configuration is 2, 6. So you can see that it is short of 2 electron to complete the octet. So that 2 electron it will share with another oxygen atom. After sharing, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So oxygen molecule is an example of double covalent bond compound. Alright, because you can see two pair of electron sharing is taking place, so it is an example of double covalent bond compound. It is also non-polar due to lack of charge separation. The third we will take nitrogen. Atomic number 7, configuration 2,5. So it is short of 3 electron to complete the octet. Now that 3 electron it will get by sharing electron from the another nitrogen atom. We have to make 5 electron. 4, 5. 4, 5 and so 1, 2, 3, 4, 5, 6, 7, 8. Octet completed. Octet completed of this nitrogen also. Okay, so this is nitrogen molecule and this is nitrogen atom, nitrogen atom. Lewis dot structure. This is also non-polar covalent compound and triple covalent. Example of triple covalent bond. Triple covalent bond. Why it is triple covalent bond compound? Because three pair of electron sharing is taking place over here. Next we will take example of what? HCl. Now it is polar. It is polar compound. One electron of hydrogen and 7 electron of chlorine. Hydrogen 1 electron, chlorine 7 electron. After combination, this is the Lewis dot structure. It is also example of single covalent compound and it is polar. Why it is polar? Because chlorine being more electronegative attract the shared pair of electron a bit towards itself. So as a result, this chlorine will develop a slight negative charge and hydrogen will develop a slight positive charge. So that is why this compound is a polar compound. Next we will see the example of methane, CH4. Carbon atomic number 6, configuration 2, 4. And hydrogen we all know it is 1. So carbon is short of 4 electron to complete its octet. So that completion it will do by sharing electron with the 4 hydrogen atom. So carbon 4. hydrogen atom, hydrogen atom, hydrogen atom, hydrogen atom. Each atom has one electron in its valence shell, and this is the carbon atom. So this structure is before combination. So after combination, what will happen? So if you count, you will get 8 electrons for carbon atom and 2 electrons for hydrogen atom. So this is methane. So I hope these structures are clear to you. This is also example of single covalent bond sharing. You can see there is no double bond over here. One single bond. Structure of methane, you can see it is like this. C H H H, and it is non-polar. Even though it is made up of two dissimilar atoms, hydrogen and carbon, but the electronegativity difference is not sufficient for the charge separation to take place. No? They don't have much electronegativity difference value, and their structure is also somewhat like this. So the shared electron is at equal distance from all the atoms. Neither carbon nor hydrogen is exerting any pull on it, है ना? So it is at equal distance. So that is why it is also non-polar. Carbon tetrachloride has similar type of structure that you can draw by yourself. Try to draw it by yourself. Carbon tetrachloride. Here carbon, in place of hydrogen you have to put chlorine, and you have to show 7 electrons like this, because chlorine has 7 electrons in its outer shell. So its structure is exactly same as that of methane, so that you can draw by yourself. If anything is left, so in your book all the structures are given. Let me check it, how many structures are remaining now. Yeah, methane, carbon tetrachloride we have done, nitrogen, water. Okay, next we will do water. Structure of water molecule. Water will, we all know its formula is H2O, hydrogen atomic number 1, oxygen 8, configuration 2,6. And here it is formed by the combination of 2 hydrogen atom and 1 oxygen atom. Overall 3 atoms are there, 2 hydrogen and 1 oxygen. This is oxygen atom, this is hydrogen atom, this is hydrogen atom. So after combination, what will happen? 1, 2, 3, 4, 5, 6, 7, 8. Water molecule. This is before combination, hydrogen atom, oxygen atom and hydrogen atom. After combination, they form water molecule in this form. And if you count the number of electron, see, oxygen has 8 electron and hydrogen has 2 electron. So its duplet and its octet is complete, satisfied, got a stable arrangement in the form of water molecule. So electron dot structure you can make by yourself. Hydrogen has 1 electron, oxygen has 6 electron, and again hydrogen has 1 electron. After combination, And water is a polar compound. Polar compound. I hope this much is clear. How to draw the structure is clear to you. What are covalent compounds? By now you will be able to define covalent compounds, how covalent compounds are formed, the three types of covalent bond, some examples, and polar and non-polar covalent bond. This much we have studied till now. Now we have to see the comparison between electrovalent bond and covalent bond, or we can say electrovalent compound and covalent compound. Comparison. Electrovalent and covalent. So the first comparison is the nature of electrovalent compound and nature of covalent compound. So we all know that electrovalent compounds are made up of ions and covalent compounds are made up of molecules. That's why we call electrovalent compound as ionic compound and covalent compound as molecular compound. Okay, the first, it is made up of ions and it is made up of molecules. So if it is made up of ions plus and minus, it is made up of cation and anion, opposite charge, attract each other, develop a very strong electrostatic force of attraction. Static force of attraction is present in electrovalent compound, whereas weak van der Waals force in the force between molecules. So first comparison is electrovalent compounds are made up of ions, and ions being oppositely charged particles have very strong electrostatic force of attraction, and covalent compounds, they are made up of molecules and there exist a very weak van der Waals forces between the constituent molecule. So second, if we say that it has a strong force of attraction, so they are generally solid and they are generally liquid or gas. Obviously, if the force of attraction is weak, then the constituent particle will move away from each other, whereas if the force of attraction is strong, the constituent particles will be close to each other, and if it is close to each other, then it will be solid, and if the particles are away from each other, then it will be either liquid or gas. So if it is solid, then definitely it will have high melting and boiling point. High melting and boiling point. Here it is low. Alright, here it is low. Now electricity, conducting, the nature of conducting electricity. In solid form, don't conduct electricity. They don't conduct, or we can say they are non-conductors of electricity in solid form. Why? Because they lack free ions. For the conduction of electricity, free ions should be there. But we are saying that it is solid. So in solid form, due to lack of free ions, they don't conduct electricity. Whereas they are a good conductor in aqueous or molten form. So if you will get question like why NaCl in solid form, NaCl crystalline form, they don't conduct electricity. Why? The reason is due to lack of free ions in solid NaCl. Why? Because the constituent particles are binded with very strong electrostatic force of attraction, not permitting the ions to move freely, and due to that the solid NaCl don't conduct electricity. Whereas in molten form, the ions are free to move, so they conduct electricity. And here they don't conduct. Non-conductors of electricity in any form. That means in any form, solid, liquid or gas, any form, they don't conduct electricity. Why? Due to lack of free ions, because the constituent particles are molecules. है ना? So they don't conduct electricity. For this thing to happen, they should have free ions. Next is ionization in solution. Ionization. So they already are made up of ions, है ना? So ionization will not take place because they already have it. They already have ionization. So what electrovalent compounds are composed of iron. So what will happen in solution? They will become mobile. In solution, they start moving. Ionization is not taking place, but if we dissolve them or add some solution, or we'll convert it in solution form, they will start moving. Whereas in covalent compound, ionization take place. Ionization takes place in polar covalent compound. So what will happen if we dissolve polar covalent compound in water? They first ionize, है ना? They convert into ions. So that is why it is we are saying that ionization take place in covalent compound, whereas it doesn't take place in electrovalent compound. Whereas in electrovalent compound, what process will take place? Dissociation. यहाँ क्या होगा? Dissociation. Here dissociation not take place. Next, solubility. So they are soluble in water. So ionic compound are soluble in water, whereas insoluble in organic solvent. Organic solvents में insoluble होते हैं and they are insoluble in water and soluble in organic solvents. One more thing is there, if we pass electricity, and effect of electricity in both electrovalent compound and covalent compound. What will happen if we pass electricity in electrovalent compound? So the ions will separate and they start moving. So they conduct electricity. So whatever appliance is connected to the circuit, it will start glowing. Whereas it will not happen in the case of covalent compound because of lack of free ions. They are formed of molecules. So due to lack of free ions, they won't conduct electricity and the appliance attached to the circuit, it will not work. So I hope this much is clear to everyone. In the next video, we will see this thing, coordinate bonding. Till then, bye bye.